Today we are going to look at exponents and start to look at radicals. This is a part one of a two-part series for section P2 to break it up for you a little bit. So there are 5 objectives in this lesson. We're only going to look at the first 2 today, which is the properties of exponents and the properties of radicals. The other 3 we will get to in part 2. So if we start with integer exponents, we are going to look at the difference between writing something as repeated multiplication or in exponential form. Hopefully all of this that we do today is review, but I know it's been a while since we've done math, so let's look at what's happening. So repeated multiplication means we actually write something out. For example, a times a times a times a times a. But if we look at it, we can write it simple in exponential form. We multiplied a 5 times, so that's the same as a to the 5th. Here, -4, we've multiplied 3 times. When we write it in exponential form, you have to keep the -4 in parentheses because it's in parentheses over here. So this would be -4 to the 3rd power. And our third example, if we have 2x, I multiplied it out 4 times. So again, everything in parentheses, you have to keep it in parentheses. If you were to just write this as 2x to the 4th, that does not mean the same thing. These two are not equal. This one says the 4 only goes to the x. Here it goes to the 2 and the x. So keep that in mind. Parentheses are important. So just in general, exponential notation is a shortcut for writing out multiplication of the same number or variable multiple times. So a to the n is just how many times we're going to multiply it out. A is called our exponent. N is called our exponent, and a is our base. So keep that in mind when we're talking about just general notation so you know what we're looking at. So we're going to look at 7 main properties of exponents here. Hopefully they are all review for you. So I have a to the m times a to the n. When we're multiplying and our bases are the same, we're going to add our exponents. So an example, 3 squared times 3 to the 4th, add our exponents together, 2 plus 4 gives us 3 to the 6th, and then make sure you simplify this, plug it into your calculator, and you get 729 as our final answer. Dividing a to the m divided by a to the n. When we're dividing, we're going to subtract our exponents. So for example, if I have x to the 7th over x to the 4th, that means I'm just going to subtract my exponents to get x cubed. Number 3 deals with negative exponents. We never want to write an answer in college algebra with a negative exponent. So you're going to want to make sure you always change them to positive. So if I have a to the -n, that equals 1 over a to the n. We move it to the bottom of the fraction, and it makes it positive. If your negative would happen to be on the bottom of the fraction, move it to the top to make it positive. So an example here, if I have y to the -4th, that would be the same as 1 over y to the 4th. Our fourth property, an easy one to remember, a to the 0 equals 1. It doesn't matter what a is, anything to the 0 power is 1. So example, x squared plus 1 to the 0. So x squared plus 1, this is all in parentheses to the 0 power, so our answer is just 1. 5, I have a times b all to the nth power. When the exponent is on the outside of the parentheses, you have to bring it into everything inside. So I bring it to the a and to the m. An example, 5x cubed. I have to bring the 3 into the 5 and into the x. So I have 5 cubed times x cubed. Make sure you simplify any numbers. 5 cubed is 125, x cubed. If I have a to the m to the nth power, so a power to a power right here means we multiply them. So for example, if I have y cubed to the -4th, I'm going to multiply the 3 and -4, gives us -12. Remember, we don't want negative exponents. To make it positive, I'm going to move it to the bottom, so 1 over y to the 12th. Same thing with division. If I have a divided by b to the m power, I want to bring that m into everything on top and on bottom. So if we look at an example, I want to bring this exponent on the outside into the 2 and to the x. So I have 2 cubed over x cubed. Simplify that 2 cubed to get 8x cubed right here. So one thing to remember, we talked about parentheses a little bit, is to know when to use them and the difference. So here I have -2 to the 4th power. It's not the same as -2 to the 4th without the parentheses. Remember, this would mean that you're multiplying out -2 times -2 times -2 times -2 4 times. If I multiply all that together, I get a positive 16. Over here, the negative doesn't go with the exponent of 4. So this negative would stay outside, and then inside we would be multiplying the 2's 4 times. So this would be the negative 16 as an answer. It makes a difference when you put it in your calculator, so pay attention. If you have parentheses, you have to keep them. If you don't add them, so you don't end up with the wrong sign on your answer. So we're going to look at a few examples of using the properties of exponents. So here, part A, I have negative 3ab to the 4th times 4ab to the negative 3. So what you're going to do if you have numbers in front of your variables, the negative 3 and the 4, we're going to multiply those together and we'll get negative 12. And then combine letters that are the same. I have an A and an A. So A times A is A squared. And B to the 4th times B to the negative 3. Remember, we add our exponents, so that would just be B. 4 plus negative 3 is 1. You don't have to write the 1. You can if you want to. Doesn't make a difference. Part B, I have 2xy squared to the 3rd power. Remember, it's a power outside parentheses, so that power has to go inside to each one of these. Remember, when there's not an exponent, it's like having a 1 there. So this is going to be 2 cubed, x cubed, and then my y, I have to multiply 2 and 3 together to get 6. Lastly, make sure you simplify any of these numbers. So 2 cubed is 8, x cubed, y to the 6th as our final answer. Part C, I have 3a times, in parentheses, negative 4a squared all to the 0. So remember, this 0 goes to everything in the parentheses, and anything to the 0 power is 1, so all of this just equals 1. So this is like 3a times 1, which would just give us 3a. And the last one, we have 5x cubed over y all to the 2nd power. Remember, that power on the outside has to go to everything in parentheses. It has to go to the 5, it has to go in here to the x, and down here to the y. So we would have 5 squared x if we multiply our exponents to the 6th over y squared. Lastly, simplify this 5 squared to get 25 x to the 6th over y squared. So that is it on exponents. We're going to move on to properties of radicals. There are 5 that we're going to look at. Basically, it's just rewriting in different forms to make your life easier when you're working problems. So the first one, I have the nth root of a to the m. We can rewrite it with that m. That m on the exponent can be on the inside of the radical or on the outside of the radical. They mean the same thing. For example, cube root of 8 squared is the same thing as the cube root of 8 with the squared outside parentheses. This one is easier because we know the cube root of 8 is 2, and then 2 squared is 4. Easier to simplify than making this 64 and doing the cubed root. So what you want to do, remember, if you don't know or remember how to do a cube root, it's under the math button in your calculator, and then you will see the cube root button that it will do for you. So you don't have to remember all that. And then part 2, the square root or the nth root of a times the nth root of b equals the nth root of a times b. So as long as those roots are the same, multiply what's underneath the radicals. So here, radical 5 times radical 7, we just multiply the 5 and 7 both under the radical to give us radical 35. Part 3, the nth root of a over the nth root of b, that can be simplified again. As long as the roots are the same, you can make one big fraction underneath the radical. Sometimes makes life easier. For example, the 4th root of 27 over the 4th root of 9 would give me the 4th root of 27 over 9 if I put them together. 27 divided by 9 is 3. Easier to simplify that way. Part 4, I have radical m, or the mth root of the nth root of a. So I have double radicals. It's kind of like our power to a power where you multiply them. When you have double radicals, you multiply your roots together. So I would have mn root of a. So for example, if I had the cube root of the square root of 10, remember this is like having a 2 right here if there's not a number. So 3 times 2 would just give us the 6th root of 10. And our last one is a good one to remember, the nth root of a to the nth power. If these numbers are the same, your answer is just what is underneath the radical sign. So it's just a. So for example, the square root of 3 to the 2nd power, remember when there's not a number, it's like a 2 here, all cancels out to just get the 3. These all cancel. So if we use the properties of radicals to do a few examples here. So the square root of 8 times the square root of 2, remember they're both square roots, so we can multiply the 8 and 2 together to get the square root of 16, and the square root of 16 is 4. Part B uses the one that I said was good to remember, the cube root of 5 to the third power. Remember, these numbers are the same, so they cancel each other out, and our answer is just what's under the radical of 5. Part C, I have the cube root of x cubed. Again, these numbers are the same. When they're the same, they cancel each other out, and we're just left with an x. And over here, again, looking at it, the 6th root of x to the 6th, these are the same, cancel to just get x again. So those are some examples, a quick reminder of using the properties of exponents and radicals. We will continue using these in part 2 of our lesson.